A block of mass 10 kg rests on the horizontal floor. Coefficient of friction 0.4. What force is required just to make the block move when pulling horizontally? 2. Pulling at an angle of 60 degrees to the horizontal. 3. If the block is pulled with a horizontal force of 50 Newton, with what acceleration does it move? Very simple and straightforward. We know we have a body on a flat surface like this, and we are told that it is 10 kg. Please, G is equal to 9.8 meters per second square. And now, we are asked, what will be the force to move it horizontally? Now, we know mu. So in this place, N, the first thing to look for is N. Let's say this is the force being pushing it. So to this force, there will be an opposite frictional force. So when this force is equal to this one, that is when motion starts. So let's call this one F. Then, that is P. N. So F is equal to mu N. In this instance, N is equal to 10 times 9.8, which is 98 Newton. So F is equal to mu N, which is equal to 0.4 times 98 Newton. Therefore, P will be equal to F in this instance, which is equal to 0.4 times 98, and that is equal to 39.2 Newton. So with all the explanations we have done in the notes, all these ones are very simple now. Now for B, we are told that the force is now 60 degrees to the horizontal. So in this instance, on resolving, we realize that N plus P sine 60 is equal to 10 times 9.8, 98 Newton. So, and we also realize that P cos 60 is equal to F, which is equal to mu N, which is 0.4 N. Yeah, 0.4 N. So you can see, all we need to do now is eliminate N and then get P. We know that P cos 60 is 0.5. Therefore, P will be equal to 2 times 0.4 N, which is 0.8 N. So N will be equal to P over 0.8. I think that's better. Now I have, in this equation, let me substitute this here. So we have P over 0.8 plus P into root 3 over 2 is equal to 98. Therefore, P is equal to 98 over and over 0.8 plus root 3 over 2. And let's see what that gives us. So that's 46.31. Now we are asked, if this force here is 50 Newton, that is parallel to the surface, is 50 Newton, what will be the acceleration? Now, in this instance, N is still the same thing as 10 kg. Therefore, 50 minus F, you can see that F is against the motion, will be equal to ma. And what is F? Mu N, 0.4 N. What is N? N is the same thing as 10 times 9.8, 98 Newton. Therefore, F will be equal to 0.4 times 98. So, 50 minus 0.4 times 98 will be equal to 10A. Therefore, A will be equal to 50 minus 0.4 times 9.8 over 10. So, let me cut it. And what does that give me? 5 minus 0.4 times 9.8. Let's see what the answer is. That is 1.08 meters per second. 1.08 meters per second square. So which is approximately 1.1 meters per second square. So you can see it is straightforward, easy to calculate. A mass of 10 kg is placed on a plane inclined at an angle 30 degrees to the horizontal. What force parallel to the plane is required? A. To hold the mass at rest. B. To make the mass move steadily on the plane. Now we have a situation like this. We have a mass of 10 kg here. Normal to the plane, there is a reaction, and this one is 10 cos 30 degrees. And we have a force going down like this. 10 sine 10g, sorry, 10g cos 30 degrees. The normal to this place is 10g cos 30 degrees, and this one is 10g sine 30 degrees. And if you look at it, considering this and the mu tan 30 degrees is greater than mu. So which means that there is tendency to move down. We are now looking for a force to hold it, a force to hold it, or to stop it from moving down. Let me put it here. A force to stop it from moving down. Now, if it's coming down here, the frictional force here, friction, and that is mu n, and n is 10g cos 30 degrees. Now, looking at it like this, you can see that along this plane, along the plane, P plus frictional force is equal to 10g sine 30 degrees. And what is n? Is equal to 10g sine 10g cos 30 degrees. Therefore, P will be equal to 10g sine 30 degrees minus 10g cos 30 degrees times mu. That is the coefficient of friction, which is 10g into sine 30 degrees minus 0.5 cos 30 degrees. And that is, you know that g is 9.8. 10 times 9.8 into 0.5 minus 0.5 times root 3 over 2. So I don't need to break it further. Let's work it out straight. A, B, C are connected by light inextensible strings, as in figure, where B is held on a rough horizontal plane, coefficient of friction 0.6. The pulleys are smooth. When B is released, what will be the acceleration of the masses? From previous work we have done, you can easily get this one straight, direct. The total force pulling in this instance, total force pulling is equal to 4g. Total resistance to the force. Total resistance to the force pulling will be equal to, we have this one, g, 1 times g, plus, you know this one is 3g, 0.6 times 3g, 0.6 times 3g, that is mu f here, mu n, sorry. That is the resistance force. What is our total mass? We have 4 plus 3 plus 1, 8 kg. Therefore, our acceleration, therefore, you can say 4g minus g plus 1.8g is equal to 8a. That is ma. So we have 4g minus 2.8g is equal to 8a. And from this, we know that that is 1.2 times 10 over 8 equals to a. So that is 12. So a equals to 1.5 meters per second square. This one is useful if it is multiple choice question. Where speed is very key. You don't need to write all this. Just 4g minus this one, you get your a. Now let's analyze the whole thing. If it is a question where we are to explain, and every step will give us mark. Now this analysis requires us to do something like free body diagram. For this one, 4 kg. Okay? There is let's call this one, the tension here is T1 and T1 here. So we have, and here we have 4g, that is acceleration due to gravity, minus t1, and this is t1 now. You can see t1. We have an equation for this. Now let's look at the second one. We have this. This t1 that goes up here will be the one that will put this one here. t1. We have 3 kg and we have 3g. As this one pulls here, frictional force will act in this opposite direction. We have n. So here, F, which is mu n, which is 0.6 times 3g. We also have another force here that is opposing this motion. That is T2. That is T2. For this one now, T2 is pulling it up, and gravity is pulling it down. Now let's look at everything here now. In this instance, this 4g is moving down with acceleration 4a, fa. So 4g minus t1 is equal to 4a. Look at this one here. T1 minus T2 plus 1.8g is equal to 3a. And here, T2 minus g is equal to a, 1 times a. So with this, we can solve all of these things. We see this from here. We can see that T2 is equal to g plus a. We can bring it here. And from there, we know what our T1 is. We can bring it here. So you see that everything is the same thing with what I did initially. And here now, T2 is equal to g plus a. So I have T1 is equal to 3a plus g plus a plus 1.8g. So this T2 is what I brought here. That's g plus a. This 1.8 too. So that's T1. So T1 will be equal to 4a plus 2.8g. Now let me bring this T1 into this equation here. So 4g minus 4a minus 2.8g is equal to 4a. So 4g minus 2.8g is equal to 4a plus 4a is equal to 8a. So 1.2g is equal to 8a. A equals to 1.2. Okay, let's see. A equals to 1.2 times 10 over 8, which is 1.5 meters per second square. So you can see it's straightforward, very easy. Just resolve, draw the first diagrams, and then collate. You get your answers. 6.565 Newton. So that is the force required to hold it. Now, to make it move up, once it goes like this, the direction of the friction comes down. So friction will now come and join this one for this one to move it up. So P. So as P is moving it up, friction comes down. You know, we have said that friction always acts in the opposite direction. So friction will come down. So P will now be the sum of this now. It must overcome this friction and then overcome the 10g sine theta. So P, this is the force that moves it steadily on the plane. Will now be equal to P. There is no acceleration. Will be equal to mu n plus 10g sine 30 degrees. And we have no n is 10g cos 30, mu is 0.5. So which is 0.5 times 10g cos 30 degrees plus 10g sine 30 degrees. And we can still break it further and say 10g, this one is 0.5 times 0.5 into cos 30. This cos 30 is root 3 over 2. root 3 over 2 plus 1. Sin 30 is 0.5. So I factorize this. So it's going to be 5g into root 3 over 2 plus 1. So 5 times 9.8 times root 3 over 2 plus 1. So let's see what that one gives us. So that is 91.44. 91.44 Newton. So when it is moving it up, you can see. But when it is stopping it from coming down, you can see the force. A parcel of mass 10 kg rests on a lorry. When the lorry is accelerating at 1.5 meters per second square, the parcel is just on the point of sliding backwards. What is the coefficient of friction between the parcel and the lorry? This is what happens. We have a parcel on. This is the portion of the lorry on which the parcel is resting on, and the parcel is 10 kg. So which means that we have 10 g Newton. And when this one is at the point of 1.5 meters per second square, this parcel breaks. You understand? This parcel breaks from the lorry. Like, you know, I told you it's like adhesion, something joining another one. So this force up forward breaks the bond between this one. So that forces this one to go backward. And what is the force to the front? That is, this one is 10 times 1.5 Newton, mass times acceleration. And it's now equal to the frictional force. Therefore, F is equal to 10 times 1.5 Newton. And at the same time, F is equal to, because the reaction here is N, F equals to mu N. N is the same thing. Since it's not sloping, it's still on a straight line, parallel to the horizontal. N is still 10 g Newton. Therefore, F equals to mu times 10 g, and it's still equal to 10 times 1.5. This one cancels this. So mu, the coefficient of friction, is 1.5 over g, and that's 1.5 over 9.8. Let me calculate that. That is 0.153. 0.153. So that is the coefficient of friction. I hope you understand. This force on this place breaks this one to go backward. And this force is equal to 10 times 1.5. So that calculation has shown it. An iron block of mass 10 kg rests on a wooden plane inclined at 30 degrees to the horizontal. It is found that the least force parallel to the plane which causes the block to slide off the plane is 100 Newton. Calculate the coefficient of sliding friction between the wood and iron. Now, we have a situation like this. And we are told that this one has a mass of 10 kg. And the force, this force that pushes it up, is 100 Newton. We are now asked to find mu. Now, very good. Let's look at the parameters we can bring out. The N reaction is 10 g cos 30 degrees. We have been told that this is 30 degrees. And we also know that we have a portion of 10 g sine 30 degrees down. At the same time, we now have F, the frictional force. F, the frictional force. And F is mu N. Now, we can now add this one to be equal to this. So 100 is equal to 10 g sine 30 plus mu times 10 g cos 30 degrees. And we can see that this is equal to 10 g into sine 30 plus mu cos 30 degrees. So we can still work this out. I say 100 over 10 as 10 will be equal to sin 30 plus mu cos 30. And you can see this one is equal to 1. So 1 equals to 0.5 plus mu cos 30 degrees. And you can see this one is going to give us 0.5 is equal to mu cos 30. So mu is equal to 0.5 cos 30, 0.5 over root 3 over 2, which is 1, or let me get 2 times 0.5 over root 3, 1 over root 3. And what is our mu? That is 0.5774. So our coefficient of friction is 0.5774. In each of the following situations, find 1. Acceleration, 2. Tension in the strings, 3. Magnitude of the frictional force. You can see we have the coefficient of friction and the masses. Now let's make our G to be 10 meters per second square. Therefore, we have a force against the frictional force against motion in all of them. So in this case, frictional force will be equal to 0.25 times 15g. And here we have this one to be 5g. So let's call the tension here to be T and T. T here will be equal to T here. And by third law of motion, this one will act to be equal in the opposite direction. Now let's start. T minus 15 times 0.25, 15g, sorry, that is 150, times 0.25 is equal to 15a. 5g, that's 50, minus t is equal to 5a. So from here, adding these two, I'm going to have 50 minus 0.25 times 50 is equal to 28. So A will be equal to 0.625 meters per second square. That is A. We have gotten the magnitude of the frictional force because it's perpendicular. I've gotten that one to be frictional force is equal to 150 times 0.25, 37.5 Newton. And in this instance too, the T, tension, will be 50 minus 5e, and that is equal to 50 minus 5 times 0.625. The tension is 46.875 Newton. So the tension in the rope here is 46.875 Newton. Now let's go to the next one. The frictional force here is 0.1 times 20, and that is 2 Newton. Let's look for what the acceleration is. Acceleration. So here we have T and we have T here. So T minus 20 times 0.1 is equal to 2a. 1 times 10, that is G, minus T is equal to A. So adding these two, I have 10 minus 2 is equal to 3A. So A equals 8 over 3 meters per second square. That is A. And now T. To find T now, it will be 10 minus 8 over 3 is equal to 2. And that is equal to 30, that's 22 over 3 Newton. Now let's look at this here. Let me say T1 here, T1 here, T2 here, okay, I have three equations to develop. The frictional force in this instance, I will take my time to check it. If there is motion, I'll be able to get the frictional force. If I can't get, if it doesn't get to the limiting friction, I won't be able to get. But let's see what it will be like. Now, 80 minus C1 is equal to 8A. And this T1 must overcome this one, for motion to take place at all. So let's see. So T1 minus 0.15 times 20 minus T2 is equal to 20A. So T2 minus, this one is 200, please. T2 minus 40 is equal to 4A. Now, T2 will be equal to 40 plus 4A. Okay, let's see what it will be like. 80, let's add the 3. 80 minus this, and that is 80 minus 0.15 times 200 minus 40, that is 10, will be equal to 32A. So A will be equal to 10 over 32. So if A is equal to 10 over 32, let's see, what will T1 be? It will be equal to 80 minus 80 over 32. And that is 80 is 10, 80 is 4. So 80 minus 2.5. That is 77.5 into. For T2 will be equal to 40 plus 4 times 10 over 32. And that's going to be 41.25. Okay, let's now check this place. If this one occurs and we are able to get this one correct, it means our frictional force is this. So let's see. 77.5 minus 0.15 times 200 minus 41.25. So I have 6.25 is equal to 20A. So in this instance, A will be equal to 6.25 over 20. Let me see. 0.3125. And is it the same thing with this? So our frictional force in this instance, Fr is 0.15 times 200. Now here, we have 1 kg here, we have 3 kg here, we have 8 kg here, and mu is 0.3. Let's make this one T1 and T2. So, you can now say G, that is 10, minus T is equal to A. For this place, C1 minus 8 times 0.3 minus T2 is equal to 8A. For this one, C2, okay, no, sorry. I have to start from the other side because that one is greater. So for this one, we have 3 times G, that is 30, minus T2 is equal to 3A. So T2 minus 80 times 0.3 minus T1 is equal to 8A. So T1 minus G, that is 10, is equal to A. Now let's find A by adding this one and this one, everything. So everything here is equal to 11A 30, 20 minus 24. So which means that the force generated is not enough to pull this one and this one. So at the end of the day, A is equal to 0. There is no motion. This is 0. So T2 will be equal to 30. So T2 will be equal to 30 Newton. T1 will be equal to 10 Newton. And the frictional force generated will be equal to, but since it's less than 24, but the force being applied. So Fr will be equal to this T2 minus T1, which is equal to 20 Newton. The force generated, the frictional force generated is not to mu times normal, but this is the one they were able to generate. The brakes on the caravan of mass 700 kg have ceased so that the wheels will not turn. What force must be exerted on the caravan to make it move horizontally? Mu equals to 0.7. Here, you have a caravan like this. And the wheels, they are not turning now. So, which means it is going to slide. And we are told that the mass is 700 kg. So let's make G 10 meters per second square. So the force required now, because the normal reaction will now be mg. So F that will pull it must overcome the frictional force. So F, or let me say P, is equal to frictional force, and which is equal to mu n, and n equals to mg. So which is equal to 0.7 times 700 times 10, and that's going to give us a block of mass 5 kg is resting on a rough horizontal surface. The block is being pulled by a lightning extensible string, which makes an angle of 25 degrees with the horizontal. The tension in the string is 15 Newton. Given that the block is on the point of sliding, find 1. The normal reaction between the block and the surface. 2. The coefficient of friction. Now we are made to know that the body is about to slide. That is, it has reached the friction generated has reached the limiting frictional force. So motion is impending. So we have situation of impending motion. From what we have now, friction will come here. This one will go in this direction. Here we have F. This is the frictional force. It always opposes the motion and the force generating the motion. Therefore, from what we have here now, F is equal to 15 cos 25 Newton here. Cos 25 degrees Newton. 5 times G, because is equal to normal reaction plus T, that is 15 sine 25 degrees. So from this, we can know our frictional force and our coefficients of frictional force. So from here, let me see. Normal reaction is equal to 5, and let's make G 9.8 meters per second square. So times 9.8 minus 15 sine 25 degrees. And what does that give us? 42.66 Newton. For the frictional force, we have that to be 13.6 Newton. So we have gotten our normal reaction. This is our normal reaction. Our coefficient of friction is equal to F over N. Since it is at the point of sliding, impending motion, that will be 13.6 over 42.66. And that is, so this is mu. 13.6 divided by 42.66. That is 0.32 approximately. 0.32 approximately. So you can see N can vary depending on the line of direction of the force that is pulling it. So it can affect the value of N. Paul is cycling at 12 meters per second. When his bag falls off the back of his bicycle, the bag slides a distance of 9 meters before coming to rest. Calculate the coefficient of friction between the bag and the road. So in this instance, we know that the frictional force is constant. Let's take it like that. So when the bag falls off the bicycle traveling at 12 meters per second, it means it also has that velocity. So V, U for the bag is 12 meters per second. V, that is the final velocity, is 0. The distance traveled for you to get to this is 9 meters. So let's calculate what the retardation is. So here we have V square equals U square plus 2AX. Now what is our V? 0. What is our U square? 144 plus 2 times 9A. So A is minus 144 over 18. So let's see. 6 here is 3. 6 here is 2, 4. So 6 here is 3 here is 8. So I have 8 minus 8 meters per second squared. That is the retardation. Now, if you look at it, the force acting against the bag now, F will now be equal to MA, which is 8N. And, 8N. And the weight of the bag, weight of bag is equal to mg. So G is 9.8. So we have 9.8 N. NA 9.8 N. So mu is FR over weight, which is 8N over 9.8 N. So mu will be equal to 8 over 9.8. And what does that give me? So mu is approximately 0.82. A boy slides a piece of ice of mass 100 grams across the surface of a frozen lake. Its initial speed is 10 meters per second and it takes 49 meters to come to rest. Find the deceleration of the piece of ice. 2. Find the frictional force acting on the piece of ice. 3. Find the coefficient of friction between the piece of ice and the surface of the lake. 4. How far will a piece of ice travel if it too is given an initial speed of 10 meters per second? Now, we have this information. M equals to 0.1 kg. U equals to 10 meters per second. S equals 49 meters. And V equals to 0. Now we work with this. We are asked to find the deceleration. So we can get that one using V square equals to U square plus 2AX. And what does that give us? 0 is equal to 100 plus 2 times A times 49. So A is equal to minus 100 over 98. And that is minus 1.02. That's the acceleration. So deceleration is minus acceleration minus 1.02, and that is equal to 1.02 meters per second squared. So we have found the first one. We are now asked find the frictional force acting on the piece of ice. Find the frictional force acting on the piece of ice. The frictional force will be equal to the force that is against this motion. So let's find the force against this motion. Force against motion is equal to MA. and we have found the deceleration, and that is equal to 0.1 times 1.02 Newton. Sorry. And that is equal to 0.102 Newton. Very easy. So this is the force against the motion, and it is equal to the frictional force. Now, third one. Find the coefficient of friction between the piece of ice and the surface of the lake. So 3. Mu is equal to frictional force over the normal reaction. And in this instance, the normal reaction is equal to weight, since it's not sliding and no other force is acting against it. So this one now is 0.102. And what is the weight? 0.1 times 9.8. And that is going to be 0.102 divided by. That is 0.104. Yeah, 0.104. The last part is saying, how far will a piece of ice travel? How far will a piece of ice travel if it is given an initial speed of 10 meters per second? Sorry, please. How far will a piece of ice of mass 200 grams travel? We know that. No, this one is 3. We know that the force, the frictional force, is proportional to the weight. And since the body is given double momentum, and the force against it will be double, it will, at the end of the day, travel the same distance. Distance traveled, since mu is constant and u is equal, is, what is that, 49 meters. So if you subject it to calculation and every other thing, you will realize that it is 49 meters. A car of mass 1,200 kilograms is traveling at 30 meters per second. When it is forced to perform emergency stop, it will lock as soon as the brakes are applied, so that they slide along the road without rotating. For the first 40 meters, the coefficient of friction between the wheels and the road is 0.75, but then the surface changes and the coefficient of friction becomes 0.8. 1. Find the deceleration of the car immediately after the brakes are applied. 2. Find the speed of the car when it comes to the change of road surface. 3. Find the total distance the car travels before it comes to rest. G is 9.8 meters per second squared. Now we can see, we have some information. The initial velocity is 30 meters per second. And we learned that mu, the first one, is 0.75. The second one is 0.8. And we are made to know that over the surface with this, it traveled 40 meters. We are now told to find one, the deceleration of the car immediately after the car brakes are applied. This determines the deceleration for the first part, and this determines the deceleration for the second part. Now, what do? We know that the frictional force acts against the motion. So, for this body now, frictional force will be equal to 0.75 times m times g. That here m is the mass, and we are told that m is 1,200 kg. G, we know what g is. And this frictional force will be equal to the deceleration from this, which is equal to decelerating force. Decelerating force. And this decelerating force is equal to ma. Therefore, 0.75 mg is equal to ma. Here deceleration is a. Deceleration is equal to a. Therefore, this one cancels this. So a will be equal to 0.75 times 9.81. And what does that give us? So times 9.8, sorry, 5 meters per second squared. We are now told that it travels that distance for 40 meters. We are asked to find the speed of the car when it comes to change of road surface. The distance it traveled with this deceleration is 40 meters. Therefore, you can find S. You don't find the time. Okay. So, let's use V squared equals U squared plus 2AS. And we know what our A is. We know what our S is. We know what our U is. Therefore, we can now say where V is speed at surface interchange. Surface interchange. So, we know S to be 40 meters. A is equal to minus 7.35 meters per second squared because it is decelerating. So V squared is equal to 30 squared plus 2 into minus 7.35 times 40. So V squared is equal to velocity at the interchange is now 900 minus 588. 17. Now we have to find the total distance traveled before it comes to rest. So for us to find the total distance, we have to find the distance traveled where the coefficient of friction is 0.8. Now let's work it out. 3. Deceleration at second at surface where mu is equal to 0.8 with equal to is 0.8 times 9.81. 9.8. We have gotten that relationship from the first question. And that's going to be 7.84 meters per second squared. So we have been able to get that one. Velocity on getting to this point is this. So here, U is equal to 17.66 meters per second. You have gotten that. Now, for us to get the distance over this surface, S2. But we know that V2 is equal to 0 because we asked when it comes to rest. Therefore, we have a situation like this. V2 squared is equal to U2 squared plus 2AS. S2. Let me make it S2. So what is our V2? Therefore, 0 will be equal to 17.66 squared plus 2 times minus 7.84 S. You know, we have gotten this and it is accelerating. Therefore, we can now say, and this is our V squared. So 312 is equal to 2 times 7.84 S. So S, the distance traveled, S2, sorry, is equal to 312 divided by 2 times 7.84. So S2 will now be 19.9 meters. 19.9 meters. Therefore, total distance traveled. So, total distance traveled will be equal to the initial S plus S2 before coming to rest, which is 40 plus 19.9 meters, which is 59.9 meters. Very good. Peter, whose mass is 30 kg, is sitting on a sledge of mass 10 kg, which is being pulled at constant speed along horizontal ground by his brother Steve. The coefficient of friction between the sledge and the snow-covered ground is 0.15. Find the tension in the rope from Steve's hand to the sledge when the rope is horizontal. 2. The rope makes an angle of 30 degrees with the horizontal. Now we have a situation like this. This is the sledge. And we have Steve. No, we have Peter on it. So the total mass here is 30 plus 10. and it's now being pulled on an ice covered ground. The air mu is 0.15. So we have total 40 kilograms. And we are told that the brother Steve is drawing it here. And the speed is constant, which means that is equal to the frictional force. And what is the frictional force? In this instance, N, the reaction, perpendicular reaction, normal reaction, is equal to 40 G. That is the normal reaction. And so, frictional force is equal to mu W, which is mu N. Let me put it mu N. Where N is 40 G. This one is not affecting it. We have it to be 0.15 times 40 G, and G is 9.8. So P is equal to F, which is mu N, which is 0.15 times 40 times 9.8, and that gives that gives 588 Newton. That gives 588 Newton. Now we are told that P is now being projected 30 degrees to the horizontal. So, which means that it is now reducing the normal reaction that we ought to have. Now let's see how it will be. Normal reaction is upward, like this, against this one. So P, we have P that goes up, we have P along this direction too, due to the inclination. So we have N. And F equals mu N. So let's see what N will be. For us to have P and to have constants, we have the frictional force, which is mu N. So we have this, we have this, we have this, we have this. Now from this, we can use resolution of vector. And now we can say N plus P sine 30 is equal to 40 times 9.8. Along this place, you can see that P cos 30 is equal to F, which is 0.15 N. And this is mu and N. Now let's make N the subject of formula here since we know it's straight. So we can say N is equal to 40 times 9.8 minus P sine 30 degrees. Then you can now say, let's now substitute this for N in the second equation. So we can say P cos 30 degrees is equal to 0.15 into 40 times 9.8 minus P sine 30 degrees. Now let's bring this to the side. You can now say P into cos 30 degrees plus 0.15 sine 30 degrees is equal to 0.15 times 40 times 9.8. Therefore, P will be equal to 0.15 times 40 times 9.8 divided by cos 30 degrees plus 0.15 sine 30 degrees. What does that give us? It gives us 62.49 Newton. It gives us 62.49 Newton. Another way we can look at it is this. Since we are going to find P, N is perpendicular to this place. This angle here, we can know it. The angle of friction. And this angle, theta here, is arctan 0.15. And what is that? 8.53 degrees. So this place is 8.53 degrees, and that is the resultant of N and F. So we have something like this. P 40 times 9.8 and R. This place is 8.53 degrees. So you can use triangle of forces. You can also use Lami's theorem. Anyone you like. You know that this place is 30 degrees. So this place here will be 60 degrees. This place is 90. And this place will be 180 minus 8.53. And this one is 171.5 degrees. Or 0.47 degrees. Yeah. So if I use Lami's theorem, I will have this one 40 times 9.8 over sine 58.3 will be equal to P over sine 171.47 degrees. Let's see what that gives us. P will be equal to 40 times 9.8 sine 171.47 over sine 68.53. Let's see. Now, since the body is having constant velocity, it is in equilibrium. So we can draw our force diagram like this. So we have P like this, and we have 30 degrees. We have N perpendicular to the surface. We have 40 times 9.8, 62.5 degrees. That is 62.5 degrees. So if I want to draw the triangle of forces, let me tell you how it will look like. So I have something like this. Can you see? I have this one and I have this one. So this one is 40 times 9.8, and this is my P, and this is my R. You can see how easy it becomes. So this one, this P is 30 degrees to this place, and this one, you can see, is 8.53. So you can see what I have here. This place is 60 degrees. I have 30 degrees here. And this place is, I would have gotten it straight, the alternate angles, 8.53 degrees. Now, since I have gotten this, I will just use my normal sine rule, because that's where Lami's theorem is even gotten from. So I can now say 40 times 9.8 over sine 111.47 is equal to P over sine 8.53 degrees. Now, P is equal to 40 times 9.8, please. 40 times 9.8. 40 times 9.8 sine 8.53 over sine 111.47. This gives me so this one is also 62.5 approximately. 6.5 meters. So you can see, you can arrive at the answer using any technique that is, you like. And essentially, you can easily take two forces together, especially when you know the direction and the magnitude, to reduce the number of forces you are going to deal with. And then you can come to get either two equal forces, opposite equal forces, or triangle of forces. So this helps in handling vectors or forces easily.